For 12.1, we are going to be working on exploring solids. So in this chapter, we're going to be doing volume and surface area. So first, let's look at some of the solids we're going to be looking at. Starting with a little bit of vocabulary, a polyhedron is a solid that is bounded by polygons, called faces. So the faces here would be the trapezoid, and then you've got a rectangle there, all on the sides, and those are the faces. And so those faces enclose a single region of space, which would then conclude would be your polyhedron. So if we look, we have faces here, here, top, and there's faces on the bottom, left, back as well. And the things that enclose the face would be the edges. The edges are the black lines that go around each of the faces. And finally, where the edges meet, they create a vertex. And there's multiple vertices in this picture. So just for example, we have this one here. The faces also, or the edges, excuse me, touch here. Edges are touch here and here. So we have to know the faces, the vertices, and the edges of all the polyhedrons. And so let's look at some types of polyhedrons. So these, we have prisms, we have pyramids, and what you can see, these are all enclosed by polygons. So a rectangle, we have triangles, we have squares here in the pyramid possibly. So these are polyhedrons because there's polygons that entrap them. And these, so a cylinder, cones, and spheres are not polyhedrons. And one really easy way to look at this, there's no polygons that are enclosing any of these regions, but also they are curves. They are curves in the shapes. Therefore, they will not be polyhedrons. And let's look at this example. It says, tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Well, the first thing we need to do is name the polyhedron, or well, decide if it is a polyhedron. And A, it is indeed a polyhedron. It is enclosed by polygons. I see some rectangles here. And this is a prism, and since we have rectangles, we will have a rectangular prism. So we have rectangular prism. And the next step, we need to count the number of faces. And I'm going to put F down here, and that's going to be faces. So when I count these, I'm going to start, I'm just going to basically put numbers on all of these. So we're going to count 1, 2, 3, 4 goes on top, 4 is on the top, 5 is on the bottom, and finally we have 6 on the back. So I like to count these and I like to number them. So we've got 1 on the front, the back, side and side, and then top and bottom for a total of 6. So we have 6 faces. And let's change colors here, and we're going to try to find the vertices. So for the vertices, I'm going to mark those in, let's go with green. We're going to mark those in green. So if we're marking the vertices, remember that's where our edges connect and where they touch. So we have one vertex there, here, here, and here. So I'm going to add those up. So that's on this face. So I have vertices, so we're going to call that V. We have 4, and we should have more, so I'm going to do plus. I see vertices here, 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 and finally on the back, which will be another one. So we have 4 back there, which will give us a total of 8 vertices. So we have a total of 8 vertices so far. And last but not least, we need to count up the number of edges. So we will do that in purple. So the number of edges, and we already have some red lines marked for the edges, so I'm going to continue with those. We have, this is 1, 2, 3, 4. So I'm going to make E right here. I'm going to say E for edges, so I know we have 4. And we can continue on the back, so we do front to back, so that's 1, 2, 3, 4. I would highly suggest that you guys are using colored pencils or a pencil and a pen, just something so you can keep track of which ones you've counted so you know. and it's going to help you identify what you are counting. That's why I'm trying to use different colors as well. And so we have to make sure we don't double count. This is where it's important. So we look at our right side. I've got 1, 2. I've already counted these. So I've already counted these, so we can't double count them. So all that's left over there is 2. So we're going to add 2. And we'll count the left side. So we have 1 and 2 as well. Remember, we can't double count because we already have these here. So we just add 2. And this will give us a total number of edges of 12. Okay, at this point, you should be feeling somewhat comfortable with counting up the faces, the edges, and the vertices, and naming these solids. So I'm going to give you a couple seconds, pause the video, name polyhedron B, and then find the number of faces, vertices, and edges. Alright, that should have been enough time, and here we have it marked down. So for B, we have a hexagonal pyramid. So the way you name this a hexagonal pyramid, you would count the number of sides we have down here in our base. So our base is what the pyramid sets on. So we have 1, 2, 3, 4, 5, 6. So this six-sided figure is a hexagon, and together the solid creates a hexagonal pyramid. So we have a hexagonal pyramid, and you can tell it's a pyramid because, once again, all of them come up here and connect to one vertice. And it is indeed a polyhedron, which is covered in polygons, so it encloses the solid. The number of faces should be 7. There should be 7 vertices and 12 edges. If you're having problems counting these, remember, try to use different colors and make sure you're not double counting. Finally, it says, tell whether the solid is a polyhedron. If it is a polyhedron, name it, and then find the number of faces, vertices, and edges. So for C, we know this is not a polyhedron. It is not covered in polygons. What we have is a cone here. So this cone, since it's curved and it has a circle, we know that this is not a polyhedron. So this is not. Okay, and for this, it says, tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. And I'd like you to pause the video, and I'd like you to try the 3 of these on your own. Okay, could have had enough time there. So we have number 1. So this solid is a polyhedron. It's covered in polygons. We have triangles and a square. And it says we have 5 faces, 5 vertices, and 8 edges. And remember, if you're having trouble counting these, try to use different colors, use different methods. And you got to remember, you can't double count. And by the way, what we're formed here would be a pyramid for number 1. Number 2, it is a curved square, so our square is curved at the bottom, so therefore it is not a polyhedron. And finally, number 3 is a polyhedron, and that is a triangular prism, and it has 5 faces, 6 vertices, and 9 edges. So you guys need to make sure that you're getting these correct. And when you're looking at these, remember, I've said this a few times, use different colors, different line markings. So if you're counting the faces, if you wanted to, you could use X. You could use X for all the faces, making sure you're getting them all. And finally, if you wanted to do the edges, you could, put squiggly lines on them, different colors, whatever you have to do to make sure you can count them up correctly. And here we have Euler's theorem, and it says the number of faces, F, vertices, V, and edges, E, of a polyhedron are related by the formula F plus V is equal to E plus 2. So we have our faces plus our vertices is equal to the number of edges plus 2. And let's look at this now. We're given what looks like a cube or rectangular prism, so we will use black here. And let's count up the number of faces. So our number of faces, we have 1, and then 2, and 3. So these are the ones that I can see, but remember, this continues back this way, down here, and across. So we'll have 4, 5 on the back, and then 6 on the bottom. So the number of faces we have. So we have 6 faces. So let's put a 6 here. And now let's count up the number of vertices. And we're going to do vertices. We'll do those in blue. So we'll do vertices in blue. So we have where the edges connect, make the vertices. So we have 1, 2, 3, 4, 5, 6, 7, and finally, remember the one down here, 8. So I'm going to have 8 vertices. It is equal to the number of edges plus 2. Let's count up the number of edges we have, and for that we will use green. So let's use the green, and we have edge number 1, so edge 1, 2, 3, 4, so that's the front. Let's go to the back. 5, 6, 7, 8, and finally on the sides we have 9, 10, 11, 12. So we have 12 edges, and we add 2. Okay, so if we look at this, on the left hand side, 6 plus 8 is 14, and we have 12 plus 2, which is also 14. So we know we're correct because our faces plus our vertices is equal to the number of edges we have plus 2.